I make that mistake a lot. Okay, I got to turn the microphone on. Everyone, thank you for joining us. This is going to be an online lecture, and we announced this previously, but the Visualization Studio is a fantastic space for VR. However, we are not doing VR, right? We are moving on to augmented reality. We are moving on to Project 2, and so a few other courses will be making use of the Viz Studio in the next couple lectures, okay? It'll be today. That's going to be online only, and then it is going to be Wednesday, and then we'll be back. We'll be back in the Viz Studio, okay? So let's go ahead and get started. This might, if we go really fast, maybe lack of questions. We'll get done a bit early maybe, and we'll see how it goes. But let's go ahead and take a look. So you are submitting and finishing your P1 postmortem. I really enjoy reading those. We'll have grades to you very soon. It's a really important kind of part of our feedback process, being able to read and kind of understand how the experience of a project is for you. That helps us change it and improve it over the semesters. So thank you for doing that. Today, we need to launch Project 2, and we're going to launch P2 Milestone and P2 Project Management. We'll see in just a moment that that's going to be very similar to Project 1, Project Management. But let's go ahead and first, I want to actually show you another XR company. This is a really cool one. This is one that uses AR very heavily, and it's one that might feel near and dear to your heart if you've ever done a kind of science laboratory experiment in high school or middle school. If any of you remember the science laboratory where you get to dissect a frog, some people dissect the frog, other schools have you dissect something else. But this is a tool, Frogopedia, that basically facilitates you being able to do that. Go in and do a science experiment, dissect a frog, right? Learn about biology. And interestingly, it allows you to do all this without actually having to open up a real frog, right? If you think about the logistics of, okay, we need to dissect frogs. Well, are there just places where you can buy like large amounts of dead frogs for dissection, right? Well, there are, but it's kind of an unusual thing, right? Might be kind of expensive to source that stuff. And then there's the question, the ethical question, right? Should we be, our frogs being harmed by the fact that we do these experiments? And so when you look at an app like this, Frogopedia, this is an application that allows you to visualize the frog, right, in its live state, right, using all of its muscles, and you can show it kind of through its life cycle, and then you can go into it and kind of identify how the frog kind of works internally. I think we have a footage here. Let's see if we can go ahead and watch it. By the way, this is live, and I am checking the Twitch live stream, the Twitch chat. So if you have any questions during this lecture, go ahead and ask them in Twitch chat, and then I will go ahead and answer as soon as I can, okay? Let's go ahead and check out this demonstration video.
So that's how you do it. You first need to pin the frog to the surface. So you just do it in a very professional way, like a real scientist. Then you need to cut the frog and to open her skin, I guess. We also want to show you how she did it with the actual pencil. That's how she pinned it. And she will start opening the frog and cutting the skin in a moment. These are the cuts. The app is directing you to show you what you would supposed to do and when and where. That's opening the skin.
Right, so you are going through the kind of typical dissection experience, and this is fairly familiar to me, even though it's been a while since high school. Right, What's really cool is not only can you kind of go and see some of the internal organs like you normally would, but the app is capable of providing you additional context based on what you're looking at, right? So if you don't realize that this is the liver, you will because of this app, and you'll get some additional information about what it does and why it's important that it's in there, right? So the app kind of allows us to put information closer to where people might want it, right? Move the information closer to the moment where people might need it. As a result, learning outcomes may improve. Anyway, right, so you've got some challenges. You're trying to find different internal organs of the frog. Here's the kind of explicitly AR mode, right? You can, after dissecting the frog, you can go and you can kind of look at the frog in its fully functional state. You can move it around. You can do a big zoom in, I guess, or seeing this footage. In a moment, we'll see a really cool feature here. It's a little bit creepy, actually. But we can actually change how this frog renders. So we can remove the skin while it continues to animate, and we can see how its muscles kind of are layered inside of it to give it structure and allow it to do certain things. Okay? I think there's also a bone mode as well, yeah, which we'll see right here, right? So kind of getting a feel for how the frog's biology works looks like it's improved. Oh, and this is what's really cool. This is the nervous system, right? So you've got all these nerves kind of connecting to a brain in here, to the eyes, yeah. I think we just got a spam. Let's see here. Yep. Cool. And so let's take a little bit of a closer look, right? So this is an app that allows you to study biology and anatomy via virtual frog dissections and educational materials. It's based in Mumbai, India. And if you look at the name, you might have guessed this is an Indian company by Individual Learning Limited. One really interesting thing about this application is that they don't sell a subscription. They actually sell a premium app. So you can buy this and then you can use it over and over again. One thing that's really interesting here is that if you are selling this kind of application not to an end user, but to a school, right? You know, can the school purchase one copy of this application and then use it everywhere? If that's the case, then this company might have a business model problem where it isn't able to keep funds coming in over time, and maybe has misidentified who its customers really are. If this kind of application allows high schools, middle schools to lower their scientific experiment costs, then there could be quite a bit of money to be made if this company were to target the schools instead of end users, maybe providing a subscription per seat, right? So schools got 20 students, that's going to be much cheaper per month than a school that has many more students. Anyhow, it's an interesting approach they've taken. They have 61 ratings, which isn't bad, but it's also not good. Probably not sustainable for a business with more than one or two people running it. And this looks like a very high quality app. If you look at their other products, they have kind of reused some of this. You can see like the same UI, some of the same features, AR features, educational stuff. They are using the same approach on some of their other applications, right? And on this one, they've got fewer ratings. They're still selling it, but for cheaper. And so it kind of looks to me like the company could have a business model problem. The good news, though, is that they're reusing a lot of technology. The applications look very cool, and it's a pretty clear win as far as social purpose goes, right? So pretty impressive stuff. It looks like on Crunchbase, this company has raised quite a bit of money. Where did that $200 million come from? Is it in here? Maybe it's been revised. Yeah, I'm not entirely sure. Financials, maybe? Financials, yeah. I'm not sure. Let's see. I'm not sure where that 200 million came from. That sounds like a lot to me. I'd be very surprised if this was true. I might need to check that out later. But a cool company, a really interesting educational use case for augmented reality, and something that could have genuine social impact as far as helping high schools, middle schools do these kinds of famous classic experiments in a way that is cheaper, maybe a bit more informative, maybe a bit more ethical. If you are a student who is a little bit squeamish on this topic and does not want to get near or smell or touch a dead frog or open it up, then this might be a really good opportunity to still allow you to do the experiment. So very cool stuff. So let's go ahead and keep going. So your Project 2 teams are finished, and I'm going to go ahead and close the group now. Let's go to self-sign-up. Right, there we go. So as I've said before, later this evening, I'm going to go ahead, possibly after this lecture, I'm going to go ahead and we're going to give random teams to all of those who don't have a team just yet. And that should hopefully be okay. Let's see here. So the Unity editor, right? You are going to be developing Project 2 within Unity, which is a famous, very well-known and well-respected game engine that is kind of aimed at beginner/intermediate game developers, whereas Unreal is a little bit more aimed at intermediate to expert-level AAA game developers. Now, Unity, despite being for a little bit more of a beginner crowd, is extremely powerful. It's a very extensible technology and tool, and I want to show that to you, okay? This is an example of the famous Doom game, running, not made with Unity, but running as part of Unity's editor, okay? And so let's go ahead and take a look. The user here is going to add onto a game object something called the doomed component, which will allow you to play Doom while you're in Unity, working on your homework. Let's take a look. So, a pretty surprising thing, right? So, Doom has a long history. It's a very classic and well-known game, but it's also an open source game. You can find the Doom engine online, and it's also a very portably written game. And so often, it does not take a ton of effort to move it from platform to platform, from console to console, computer to computer, and Doom often shows up in unexpected places, like in the Unity editor. It is something of a hobby for many people to go and see. They get into a new ecosystem, a new platform, a new piece of hardware. Can it run Doom? And the answer is almost always yes. So, very cool stuff. When it comes to AR, a very big area of advancement has been how do you synchronize multiple clients, multiple devices, multiple people who are using AR? How do you synchronize them so that they see a shared version of the world? If they could do this, that would allow them to have shared experiences. I want to show you some experiments done on this. This is pass-through AR plus multiplayer. So I think people wearing maybe Oculus or MetaQuest 2s or maybe MetaQuest, I don't think MetaQuest 3s, because you'll see here the pass-through footage is black and white, right? So on the MetaQuest Pros in the Viz Studio, this would be not super high res, but it would be in color. And so here we have an augmented reality game where we have edge detection and we have surface detection, right? So when these cubes are shot out of the cannon, they hit a wall and they bounce around, they explode, okay? But what's really interesting here is that there you go. You can see another player, right? And that player is able to spawn those objects roughly where you'd expect them to. and the player is able to shoot you as well. You can shoot at them, and I believe you can hit them, and you can also see their weapon. And so we have here two clients that are communicating to kind of figure out what the shared space is. One pretty interesting thing, and you just saw it right here, that I think this looks really cool. However, there are some problems. So if you look at this cube right here, this one right back here that's kind of on the other player's hip, you can see that it's supposed to be far away. It's supposed to be near the kind of doorway over here. The human, in contrast, is much closer to the camera. Now, there's this idea of occlusion. Things that are closer to the viewer, closer to the camera, should occlude or block out things that are further away so you can't see them. However, when it comes to modern AR, occlusion is a little bit of a thing, but also not always supported very well. And we'll talk about that a little bit more when we get into the inner workings of AR lecture. However, this is just to say, if this were all working perfectly, this block right here, and I think this block up here, would not be visible because the human would occlude it. The human is closer. So when you see something like this, it looks very strange, but what's happening is that the software does not fully understand where things are, okay? It understands where this gun is, and it understands where these blocks are in relation to each other and the gun because they're digital objects. But as soon as you're using real-world data or footage or imagery, it doesn't have a good understanding of where this human is. It might not even understand that this human is an actual object distinct from the background image. So this is one of the issues that people are kind of dealing with and facing. Okay, but still a really impressive result, and that looks really interesting. Hopefully this kind of stuff will keep improving. I see this and I get a lot more excited for AR again. So hopefully they'll keep it coming and figure out occlusion more consistently. Okay, as a kind of a general principle, the real world stuff works very well with other real world things. The digital objects work really well with other digital objects, but getting digital objects to interact with real world objects, very difficult, okay, as you saw in that example. Okay, you've got P2 Milestone that has released and P2 Project Management. P2 Milestone is going to be due in 1 week, okay? In fact, it's not going to be due in 1 week. It's actually going to be due a little bit earlier. This is going to be due on Sunday at 11:59. This is because we want to give you the entire fall study break, okay? So please be very careful about this deadline for P2 Milestone. Otherwise, if you submit at the normal time, which is Monday at 1:30 p.m., you're going to get that late penalty, which you don't want to get, okay? Okay, very cool. Let's go ahead and take a look at Project 2. And we're going to be making that move from VR to AR in this project, okay? And so we're going to be making a project that might feel a bit familiar to you. This is that Pokemon Go variant. We're going to call it A2 Go, all right? You've seen Pokemon Go, right? It's a experience, it's an application all about kind of augmenting the way you see things around you, right? So, right, you can see Pokemon walking around you, but you can also see that landmarks within your local community have been turned into interesting gyms or battle arenas or places where you can collect items and find Pokemon and all that good stuff, okay? It was a fantastic success when it came out. It obviously made the news, and it did a wonderful job of kind of getting people out and about, walking around and kind of seeing and experiencing their community in a way that they hadn't before. And you're going to be making something very similar to that, all right? You're going to be making it relatively quickly. You're going to have only 3 weeks, right? Actually, a tiny bit more than that. But you're going to be making a clone of Pokemon Go, where you will be walking around Ann Arbor. You will be exploring different landmarks in the city. Your mission is going to be to plant trees, because this is Tree City, USA. You'll be planting trees around the city. You will see them in first-person view, in the interaction mode, but also in this GPS map exploration mode. The trees will bring in tourism dollars. The tourism can be used to purchase more trees, and you get kind of a nice game loop going there. You unlock different kinds of trees by finding these landmarks throughout the environment. You will also be implementing this kind of first-person interaction mode, which will allow you to plant trees, but you will also be doing things such as protecting those trees from squirrels who get in there and prevent the tree from growing. Okay? Drive people away. They halt tourism. So got to appease. You're going to appease those squirrels by throwing them some acorns. Okay? And then they will head off on their own. Okay? So it is not going to be a super crazy app. It's not going to be a deluxe version of Pokemon Go. It'll be a variant with a different theme, but you will get your chance to spice it up with some unique custom feature toward the end. Okay, and you'll get the chance to make custom trees as well. Okay, you don't have to do all the kinds of trees we're going to show you in just a bit. All right, so the main way to think about this project is that you're going to have two modes. And in Unity, we're going to kind of break these down into two different scenes. Now, if you don't remember from our last lecture, a scene is basically a collection of game objects. It's a collection of actors. In Unreal, a scene is known as a map. So if you play a lot of video games, right, switching from map to map, you're basically, if you think about it, just loading in a bunch of new actors that weren't there before, and you're also getting rid of the old ones that were in the previous map. So we're going to have two scenes, two modes, you can think of it like that, in Ann Arbor Go. This is going to be the exploration mode. This is going to be the mode where you are walking around the city, you are seeing landmarks, you are seeing squirrels, you're seeing places you've planted trees, you're making decisions about purchasing more, exploring the city, unlocking new types of seeds, and you are basically doing kind of the things that you do in the map mode in Pokemon Go. Now, we only have 3 weeks, and so we need to get moving very quickly with this technology. And so we're going to grab an off-the-shelf technology. It's called Mapbox. It's very popular. And if you are ever making any sort of app that needs good support for mapping or for overhead views or anything like that, Mapbox will do that for you, okay? It won't do everything. We're going to have to do quite a bit of work to flesh this out, but it is really going to get us started very fast, okay? Interaction mode is when the Pokemon battle starts, okay? You can think of it like that. In Pokemon, this is when you go to catch Pokemon, you bump into it. In our interaction mode in A2Go, you will be looking around. You'll have that cursor, which you might be very familiar with from your first tutorial AR assignment, okay? And you will be using an inventory system to plant trees, which will then grow, generate tourism, and allow you to keep planting more trees, okay? You can see here this little switch mode button. So in Pokemon Go, you switch between these different modes by dealing with a Pokemon or by bumping into the Pokemon to initiate a battle. Here, in our version, you'll be able to switch between modes at any time, okay? You'll also be able to enter a shop at any time and purchase new seeds and new acorns and stuff like that. So it's a kind of an interesting time. You can read about the design of this entire game if you want to. There will be a currency that you'll have to decide on, and you'll need to kind of store and track, okay? Tree points, you can see in the screenshots here. Tree points can be used in this particular game, the student's game, to purchase seeds, which you can then use to plant additional trees. Anyway, I encourage you to look through all of this. It's not super long, and it'll give you a better feel for what exactly you're making. All right? Okay. So one question is, hey, this is Pokemon Go. Pokemon Go is all about moving around. So do we need to be able to, do we need to walk around a ton during the project to test these games as we make them? And the answer is Not really, okay? Only a tiny bit. So you will eventually need to do a bit of experimentation to walk around and verify things are working. However, that takes a long time, okay? So we're going to spend a part of today actually building a debug mode that allows us to walk around in the editor itself using the arrow keys, okay? Having something like this will dramatically expedite our development process because it allows us to test most things much faster, okay? Though you will need to, at some point, walk around and make sure it's working the way you expect when used in the normal fashion, okay? So let's talk about the schedule here. High-level schedule, right? We have today, right? We have a week from now, okay? A little bit after that, after the fall break. And then we have a almost 2-week period for P2 Alpha, and then the final week for Gold. You can break this project down into the typical engineering, design, and business/production assignments. Your first concern is P2 milestone. And hey, you just got done with Project 1. So you know what I'm about to show you. It's going to be in a very similar style. It is going to be a spreadsheet of tasks, okay? You have this task spreadsheet. You have various tasks, and they all have different priorities that will affect how you are graded on them. And these tasks have different milestones they need to be done by, okay? Or at the very least, you need a non-trivial implementation. Remember, you don't have to finish everything on every task to get points for that task. However, you do need to have everything completely finished by P2 Gold. So if you look P2 milestone, right, in our schedule, that's going to be due Sunday at 11:59 p.m. on the 14th. And let's see. If you keep going down, you'll find these red tasks. Those are P2 Alpha tasks. And you can see we actually have more time, 9 days instead of 7, for those P2 Alpha tasks, okay? So these P2 Alpha tasks are going to be a bit more difficult. I think you found that to be the case on P1 Alpha, at least based on things I'm reading in your postmortems. But you'll have a bit more time to do it. And then you'll have P2 Gold, a week to do a custom interaction and custom feature for your A2 Go, okay? So anyway, I encourage you to look through here, okay? A couple things I'll point out right away. Right away is that at the top here, there are a bunch of tasks that don't really go into your project. You won't be graded on these necessarily, but we highly encourage you to follow these tasks because they'll give you a lot of hints to get started quickly, right? They'll give you hints on configuring Mapbox. They will give you hints on setting up auto-completion in Unity. So you've got a nice way to explore what functions and variable types are available to you as you program. Okay? In C#, you really need that because in Unreal, you can just right-click and you can look up whatever kind of functions you want. However, in Unity, you're only going to get that if you have set up auto-completion and have that working properly, okay? Otherwise, right, we're going to do actually a bunch of these tasks together in class, okay? Today and then on Wednesday as well. So if you see this bold text, there's a very good chance we're going to cover it in a lecture. So you can go back, you can watch that lecture recording, and you should be able to knock that task out pretty quickly, okay? You're not going to have as many of those kind of tasks that we help you with on P1 Alpha, but we will still help you with a couple, including the Acorn. Okay? So let's go ahead and keep going. So you're going to have P2 milestone. That is your immediate concern, okay? And then on Sunday at midnight, we'll enter the fall break. You'll have a couple days to not worry about this course, which is very nice. We will then have 9 days of P2 Alpha. This is when you've got quite a few tasks that you have to do, and they're going to be a little bit more tricky. And then you've got that P2 Gold, where you will be able to take some time to fix everything up for final submission, and you'll be making a custom object and a custom feature, okay? And so you'll have a little bit of engineering to do and a little bit of design to do to figure out what kind of feature would make sense, and it's going to be of interest to you. P2 project management, right, is just like a P1, like a P1 project management. You're going to be breaking these tasks down that you see on the task spreadsheet. You're going to be putting them into Jira, okay? And this is meant to mainly get you experience with Jira, since it is just ubiquitous. Everyone uses it in industry, whether you like it or not. And also to kind of get you ready for Project 3, okay? P1 and P2 are small team projects. So is Jira super necessary? Yeah, you could probably use Discord or Trello or anything, email, to organize yourself. On P3, that's going to be a lot tougher. Okay, you're going to have a lot more people doing things. You're going to need to keep them from clobbering each other or stepping on each other's toes. You might have tasks that one person's doing that is a blocker for tasks another person wants to do. And so it's going to be helpful to have that stuff it's going to be helpful to have experience in Jira, okay? So let's wrap this up. We got teams of 2, just like Project 1. It's going to be the Unity engine instead of Unreal. Now, hey, if you were just starting to get a good feel for Unreal, you should know that basically anything you can do in Unreal, you can also do in Unity. The big challenge is that the syntax is going to be a bit different, right? We're moving from the visual blueprint scripting to the textual C# scripting. And so you might often need to kind of look up, hey, I know there's got to be a good function to do X, but I don't know what it's called. So you can use Google to try and figure out what that's called. You can use ChatGPT, right? What is the analog of a line trace in Unity, right? And it will almost certainly tell you raycast. It might even show you example code on how you might use it. Hopefully it won't be that difficult to transition to Unity. Remember, you're not trying to learn a particular engine, you're trying to learn game engines in general, okay? And if you really want to learn game engines, you'll make your own in the EECS 498 course next semester, okay? Game engine architecture. You will, just like on P1, submit intermediate deliverables at the end of each sprint, and these will be video demonstrations. On the gold deliverable, you'll do the same thing you did for P1. You're going to put the stuff onto your portfolio site, and you're also going to submit your source code to Canvas, okay? This project, some people regard it as easier than P1. Others, I think most regard it as being a little bit harder than P1. However, we are giving you a bit more time on P2 than we did on P1. We also are going to give you quite a bit of help over the next few days, and even next week we'll give you some help as well. And we'll make sure that you have the knowledge you need, okay? But this is to say that it's definitely not a project you want to sleep on. It's not one that you want to delay too often. Make sure that you are getting started with this project. Make sure that you engage with your team members on the project, and you can knock this thing out, hopefully, pretty quickly, okay? All right. A lot of people really like this project, and they appear to like it in large part because this is a project that you can, you've got on your phone. It's going to be running on your own device, and you can take it around. You can show it to others. You can just have a pretty good time, right? Showing it to family and friends, and people seem to like that. Okay. So, hey, that's pretty much it. All right, for P2, at least for getting it briefed and started, okay? So what I want to do is I want to walk you through how to start this project. And actually, if you look at a bunch of those tasks that are on the task spreadsheet, there are a lot of those tasks that I'm actually going to help you get started with, okay? You can see here, right? Exploration sheets development, partial walkthrough in class. In reality, this is more like a full walkthrough. So we're going to do a cheat code today. We're going to implement that kind of cheat movement that will allow us to walk around the city while we're sitting here in our chair working. That will speed you up dramatically. We're going to implement the beginnings of your orbit camera that allows you to kind of follow around the character as they move. Eventually, you'll need to add orbit controls. So if I swipe, we need the camera to kind of go around the character in an orbit. Hey, if it's been a while since you've done your trigonometry, you might want to get into that. Remember that there are hint documents for all of these tasks, pretty much, which will help you a lot. I'll be showing you how to do some other things as well. Switching modes, UI stuff. We might do that next time, the UI stuff. Let's see. Seed placement, interaction stuff, UI inventory bar. Yep, text indicate quantity. Okay, yeah, you probably don't need to do all of that for P1 milestone. Some of that, I think, is going to be in P1 alpha. Compass, acorn, squirrel. Yeah, okay. Okay, we'll get to some of this stuff tomorrow as well. Okay, so let's go ahead and get rocking. So one of the first things you're going to want to do is you're going to want to come into the agenda, or I think you can actually get it by finding the pre-built project here. I'm pretty sure it's the same, right? 5.7, okay. Is it the same? I want to make sure real quick so you don't get wrecked. Yes, it is. Okay. You're going to download this project. You're going to unzip it. And what you're going to find is a file, a project. If you point Unity at that project and open it up in, a semi-recent version, like 2022.3.37 or something a little bit newer, you're going to see this, okay? You're going to see this. It's not much, but we are currently in the interaction scene. If you go to the project pane, you will find all of the various files that currently comprise this project. This is the Mapbox starter project. And if you go to mapbox.com, I think the task has you do this, does it? Maybe. Let's go to Mapbox. If you go to Mapbox, you can log in here, you can create an account, and you will get an ID. You'll get a code that basically identifies you as a user, and you're able to go in, and I think you can customize Mapbox. Is there a thing here? Yes, here it is. You can go to Setup, and you should be able to put in your code just like that, and that will allow you to get data from Mapbox, download stuff. If you use someone else's code or my code, you will potentially run out of credits on your code, and then you can't complete the assignment. So that would not be good. You should be fine using your own code. So this is what you're going to end up with. We don't see a whole lot, right? There are some things in this scene, though. This is the interaction scene. And look at that. It has your AR session origin. It has some of your AR stuff, your AR cursor. It has some of the stuff from your earlier assignments. Let's see. What are these? Switch mode. We got spawn B, spawn A, right? You can probably get rid of these buttons, to be honest with you. I think we're going to replace them. One thing I like to do right away, okay? Well, first of all, I want to go to the other scene, okay? We're going to start in the exploration scene. Remember, this is kind of a zoomed out Mapbox kind of GPS scene, okay? And, if you just kind of click on it and play this exploration scene, let's see what we see. Uh-oh. Is it going to explode? This is something that I think just is a problem with Mapbox. On occasion, the editor will crash, okay? The editor, will freeze. It was okay, okay? All right, so Mapbox is actually running, and it's doing a demo. It's kind of in a demo mode. We can see our character, ourselves, right, walking through the city, and the city is actually Helsinki, okay? The walking, now, we're not walking through the city, right? But what it's actually doing is it's feeding a bunch of different latitude and longitude positions out of a log, a recorded log, to kind of show us what it might look like for the person to walk around, okay? If you look at this, there are a lot of problems with this, right? Number one, we want to be able to walk ourselves around. And we don't want to be in Helsinki. We want to be in Ann Arbor. And also, look at how kind of it's very like hitchy, right? It's a snappy, not in a good way. It has a very low frame rate, so it is reaching out to Mapbox, and it's getting information, and it's a bit slow in doing so. So we're going to do something to get past that as well and smooth the movement out. We also want our camera, our main camera right here, to move around and automatically follow the character. That's something it's not currently doing. I can fake it by grabbing the numbers and kind of moving it myself here, like I'm currently doing. But eventually, we want it to follow around our main character, and we want to be able to do things like swipe right, click and drag right, and we get a different camera angle, right? It kind of pivots and orbits around the character. We want to be able to swipe up to zoom in closer and down to do something like this and go up, right? And so we've got this pretty cool piece of technology, a big starter project with a ton of code, okay? Just look at all the components we got going on here. We got abstract to map, we got initialize map location, we got immediate position with location, rotate with location, right? We got a ton of code in this project. A bunch of location providers, right? What is all this stuff? Well, one of the most important skills you can develop is this skill where you kind of get good at jumping into an existing pile of code, an existing project, and kind of wiggling your way through it and figuring it out, what part of it you care about, okay? It's a little bit like you're doing very precise surgery, and you have to kind of figure out and find the things of concern to you so you can address them and tweak them, okay? And so that's what we're going to do. If you look at this right here, right, if we watch the game, we can see this character's moving around. So one question we should ask ourselves is, what is causing this object to move? If you press pause, you can try and find that object in your hierarchy. It's got to be there, okay? We found our main camera. We can actually click on this sphere, and we get a hint in the hierarchy of what it is. This is a sphere and a cube, okay, that are both parented to an object called player target. Okay, when I turn this game object off, our avatar disappears. And so this is a very strong hint that we have found the game object that is of most concern to us. So one question then is, well, why is it moving? What is causing it to move? Now, we could have lots of different components everywhere on different game objects, and one of them might be causing this thing to move. But one of the best places to start looking is usually on the object itself. It's a very good idea to have a game object, and if you want it to do something, well, you add a component to it, and that component will make it do the thing. Okay? So we got two interesting components on here, rotate with location provider. Now, this looks like it's dealing with a rotation. And rotation is cool, but we really care about position right now, location. So I'm looking at this other one, immediate position with location provider. This is a bit more interesting. Let's look inside of it. I double click it, okay? And we're going to see a bunch of code, and I'm not going to understand very much of it. But maybe we can understand just enough of it to do our job, okay? So we've got something called a location provider, and we're storing that in a variable, probably because this component wants to use it. Now, when you go to grab this location provider or use it, if it detects that it's currently null, it'll go and grab a default location provider. Okay? Down here, we have a little bit of weird code in start. This is basically allowing us to run a function. This is the function. It's a lambda right here that is initialized to true. It sets this Boolean to true once our map has been initialized. So basically, when the Mapbox map is ready to go, when it's done loading its data from the internet, this Boolean will be set to true right here. And if this Boolean is true, then late update will get past this Boolean, this if statement, into here. Here, we're going to grab a map of some sort, it seems, and then we're setting our local position. okay, to something coming from that location provider. Okay, that's a lot. All right, there's a lot going on in here, and you might be confused, and that's totally fine. Okay, but wait a second. If you look in the left here, you'll see we got our map, right? That's cool. We've got our player target. That's cool. But then we have location provider, and location provider is kind of an object that doesn't really have any visuals. It's an empty object. Here it is floating above the map here. But what it does have is a really interesting component, okay? This component, location provider factory, it has a bunch of different location providers inside of it, right? It has a device location provider. It has a provider for Android, for Unity. I guess Unity is like iOS, maybe. It has an editor location provider. That one sounds really good. This is maybe the script that causes us to get a certain location when we're in the editor, right? When you run this demo on a mobile device, it works normally, right? It shows you Ann Arbor if you're in Ann Arbor, or Detroit if you're in Detroit. But if you're in the Unity editor, it shows you Helsinki. And so I'm guessing this editor location provider, right here, editor location provider location log, whew, what a name. This script is what is currently making our character move, right? So I double click and I've got our script right here, okay? We got the Helsinki location log file. We can even look inside of this if we wanted to. And when we double click, we've got into the file. So editor location provider location log, okay? Right? I feel like we're getting a bit closer here. And we can look through it, location log file. Do we care about a location log file anymore? I don't think so, okay? So I'm actually going to get rid of this, okay? Yeah, the mock latitude, longitude stuff, yeah, right? So this is fake, okay? So I'm actually going to get rid of that. Now, we're not reading the log anymore. We don't care about the log. So I'm going to go ahead and get rid of that too. And the location enumerator, do we care about this? I don't know. I'm thinking not, okay? Now, I'm just hacking stuff out and hope I don't break everything, okay? Sometimes that's what you got to do. So on destroy, we're cleaning a bunch of stuff up, getting rid of a lot of variables, but I don't care about these variables, so let's get rid of the whole function, okay? All right. I don't know if I need to call base.awake. I don't know if that's important or not, so I'm just going to kind of leave it there at the risk of breaking stuff, okay? Now, you see, this function right here, set location, it looks like this gets called by other classes, okay? And so what I want to do, it looks like it wants to not do anything. We don't have a location enumerator, but that's a variable we don't want anymore. It deals with the log, right? This also deals with the log, so we can get rid of that. Yeah, see, did you see the comment? Loops through the log file, right? Yeah, we don't need to do that. And then what happens here, the last thing that this file, this class does, is it sets a variable called current location, and it sets it to that location enumerator. So it's kind of looking through the enumerator, which is looking through the log file. You don't have to understand what that means. The only thing you need to know is that, yeah, we don't need it, okay? We do not need it. You can comment lines like this out if you're worried you might need it later, but I don't think we need it. So how can we set this current location to something else to like test it, to see how it works, okay? This variable I think is going to be important, but we won't really know that, and we won't confirm what it does until we've set it to something of our design. Now this is a location object, so we need to create a new location. Let's create location, new location equals new location. Is that a line or what? Location, new location equals new location. Ridiculous, okay? When you go and you press dot, let me see, can we find it? Does this have a constructor? No, it doesn't. Okay, it does not. Okay, so does it have any latitude, longitude? That's looking like a good one. It's the first one on the list. It might be important, okay? The location, as described by a vector 2D. X represents latitude, Y longitude. Okay, I'm liking that. This is a type vector 2D. Now, if you know Unity, if you're familiar with it, you're probably familiar with the vector 2 data type, okay? And the vector 3 data type. So, you know, mine